So here are the key concepts and some cool down guidance from day 8 using graphs to find average rates of change. The cool down is called population of a city. So the first key concept, the first idea that we really need to figure out is average rate of change. So if we look at the graph of one day's temperature over time, the temperature, changes and fluctuates and everything like that. However, it does it like not consistently. It's not a perfectly straight line. So to say how fast something is changing, what you're usually doing is finding the slope of whatever line we're looking at. But again, this thing is not a straight line. So what we have to do is we have to use the idea of an average rate of change. And the way that we find an average rate of change is we just take any 2 points on the graph that we want to find the average rate of change over whatever time interval that is, and figure out what the slope of that line is. Now, slope of a line, as always, is determined by your change in y divided by your change in x. Normal slope equations that you've probably seen between 2 points are like y2 minus y1 over x2 minus x1. And that would be if you have like x1, y1 as a coordinate and x2, y2 as a coordinate. However, we have a slightly different way of writing that out in terms of function notation. But this is exactly the same thing. F of b is the y value over here at this second point. So this is like y2 minus f of a is the y value over here at the first point. So that's like y2 minus y1, and then b is my x coordinate at this second point, and a is the x coordinate at that point. So b minus a, it's just the same as y2 minus y1 over x2 minus x1. And that's how you calculate. So let's take a look at one of these for a second here. So if I'm looking for how quickly the temperature was falling between 2 p.m. and 8 p.m., what I'm going to do is I'm going to look at the temperature for both of those, and I'm going to go 30 degrees minus 45 degrees, which is what they're doing here, because that's the change. It went down to 30. So this point right here is 8 o'clock. Well, is it 8 o'clock? Well, how many hours? So what it is we have 8 o'clock is at 30 degrees, so we take 30 minus 45, the temperature up here, over how long did it take to get there? Well, from 2 to 8 p.m. is 6 hours. And so we get negative 2.5 degrees Fahrenheit per hour. So let's take a look at this. What is the average rate of change of the population between 1930 and 1950? Well, all you're doing is finding the slope of this line. What's the change in y? What's the change in x? You could also just come up with the coordinates, it's like 1930, 40 or whatever, but I wouldn't suggest doing that necessarily. So we're going to look for 1900 to 2000, so from here to here first, and then 1930 to 1950 next. And then for each interval, determine if the average rate of change is positive or negative. Well, average rate of change, again, is just the slope of a line. So if between the 2 points the slope is up, it should be positive. If between the 2 points it's going down, then it should be negative. And then this last question right here, in which decade, 10-year interval, did the population grow the fastest? Well, remember, the steeper the line, the faster something is changing. You should be able to just look at the graph, or you could go through and just find the average rate of changes between every decade, but that takes a little bit longer. Anyway, if you have any questions, let me know.